Hi, my dear. Uncle Jimmy. Here I am. Part F. Pump. Pump is a machine which imparts heat to the fluid flow. It is forming the mechanical energy of its driving motor into a fluid energy, which is meaning imparting energy to the flow of fluid passing through it, representing the pump head. According to the mechanism of pumping work, can be classified to two main types such as positive displacement pump and rotor dynamic pump. Positive displacement pump is the pump which the fluid is delivered in intermittent pulsating flow by a suitable agreement designed to achieve the manufacturing purpose of each type. It is subdivided to two main types such as reciprocating pump and rotary pump. Sketch of different types of pump. Look, my dear, the pump is subdivided to two main categories: positive displacement pumps and rotor dynamic pumps. The positive displacement pump is subdivided into two subcategories such as reciprocating pumps and rotary pumps, while rotor dynamic pumps is subdivided to three subcategories such as centrifugal pumps, axial flow pumps, and turbine pumps. Reciprocating pump is a positive displacement machine which delivers pressure by linear reciprocating machine for the pump elements. This motion is commonly effected by means of crankshaft mechanism, as its camshaft is in eccentric position while a piston or plunger forward and backward inside the cylinder. All reciprocating pumps are provided by inlet and outlet valves to regulate the fluid flow through the working chamber, and usually operating under automatically controlling by developing the working of fluid force. Generally, these pumps are capable of developing a high head, especially when using plungers, but their capacities are still relatively small, and for that reason, it is always have bigger sizes than the centrifugal pump. Small hand operating pumps also are commonly used for domestic demand as a handle pump, and its working mechanism is clear in front of you, my dear. Modification for the handle pump is occurred and replaced by the foot-operated mechanism, which is known as treadle pump, for using it on irrigation purpose. Treadle pump is a simple pump and is designed to lift water from a depth of 7 meters maximum and lift 5 up to 7 cubic meters per hour. For that, it is most commonly used in Africa and Asian countries to lift water from the simple open water well. Figure showing the two types of reciprocating pumps such as handle pump and treadle pump, and also the different types of it. Rotary pump is a positive displacement pump which delivers pressure by rotation and or oscillation motion of the element. These types don't need any inlet or outlet valve. In addition, no requiring to a crankshaft mechanism, but depending on drawing the fluid in at the inlet portion before delivering an adjacent volume of fluid, and by this way, a uniform smoothing flow will be obtained than reciprocating pump. The rotary pump gives a smoothing flow, as clear before, and can handle any liquid that is free from any hard to solid, and so it is suitable for small discharge and moderated lift, and generally can be classified into screw pump, loop pump, gear pump, vane pump, and piston pump. Archimedes pump, pump hood, is a type of screw rotary pump and common using up to date in Egypt for irrigation the small plots, as shown in the enclosed figure. Loop pumps consist of two wheels inside a casing, the wheels rotating in an opposite direction, while each one has two or three loops, as shown in front of you, my dear, in the enclosed figure. While gear pumps containing two gears, which are meshing together and housed inside a casing, have an inlet suction and outlet delivery. For that, there are different types according to each mechanism, such as external and internal gear. A case of external gear pumps type, the two gears rotating in opposite direction and play as loop pumps. Look, my dear. While a case of internal gear pump, it consists of an inner gear wheel fixing eccentrically inside an outer gear wheel, and so creation and crescent portion between the two wheels, acting as a seal between the suction inlet and outlet, as shown in the enclosed figure. The fan pumps most commonly using in the aeroplane hydraulic system, as it has four vanes and rotor consisting of hollow cylinder with radial slots in which the vanes flies, as shown in the enclosed figure. On the other hand, piston pumps consist of an eccentrically rotor carrying a number of cylinders, which each one has a special piston, as shown in the enclosed figure. Look, my dear, to the second main category of pumps. It is the rotor dynamic pumps. It is depending on its rotation movement and forces, while it can be classified to three types, as remembered before: to centrifugal pumps, axial flow pumps, and turbine pumps. Centrifugal pumps is economically in cost and simple in construction, and for that reason it is widely used to supply water on irrigation schemes, as it produces a smooth and steady flow shaft. It consists of two main parts: the impeller or rotor, which adds energy to water flow by increasing its velocity and head, and the casing house, which guiding water to and from the impeller, taking consideration that the impeller rotation is in eccentrically position inside the casing house, as shown in the enclosed figure. Figure showing centrifugal pump. Look, my dear, by yourself to the inlet and outlet position, and also to the impeller and casing house. Look, my dear, there are many types of impeller, such as open, semi-enclosed, and enclosed type, as shown in the enclosed figure. Axial flow pump consists of propeller turning by an amper power unit through a rotating shaft inside a casing house, acting as a discharge pipe. These pumps are really very efficient for lifting a large quantity of water from rivers, lakes, canals, and main drainage open ditches through a few meters at low pressure, and for that it is known as low lift pump, as shown in the enclosed figure. Turbine pumps is the best type for lifting water from the deep wells, classifying for two types according to the position of motor, such as deep well pump, which its motor is fixed up on the sail surface, and its motor is known as vertical hollow shaft, and submersible pump, which its motors are completely submerged under the water dynamic level in the water well. A deep well pump, its turbine should be only submerged under the water dynamic level in the well by not less than 10 meters, while motors and turbines are submerged under the water dynamic level in the well, a case of submersible pump. Look, my dear, it is an important difference. Figure showing the two types of turbine pump. such as deep well pumps and submersible pumps. Net positive suction head, NPSH. A case of shallow groundwater or open channels, the pump is located above the water surface, and so water is sucked up a short length of fixed pipe on the pump inlet. The difference in height between the water surface in the open ditch and the pump inlet is known as suction lift. Theoretically, pumps should be possible to lift water by suction up to the atmospheric pressure, while practically it is limited according to the friction losses in the suction path. The using concept for limiting suction lift is the net positive suction head, NPSH, which is specified normally by the manufacturer for each type of pump under different discharges. Hence, suction lift can be calculated as shown in the enclosed equation. Pumping head is not the pressure required on the delivery portion, but it also including the suction portion in addition to the sum of several components as shown in the enclosed equation. Look, my dear, it is very important for calculating the desired pumping head in any irrigation scheme. Pump performance or rotor dynamic pump should be tested in the manufacturing factory and publishing its general data on each label which fixes on a clear position on the pump body, such as discharge, head, power, efficiency, inlet and outlet diameter, and net position suction head in some type. On the other hand, power requirements, pumping is work which is the produce of force and distance. This work needing an energy as its practical unit of measuring is a kilogram per meter, which needing a time to be done and is calling power. The practical units of measuring power are horsepower, which is equal to 75 kilogram per meter per second, and or kilowatt, which is equal to 102 kilogram per meter per second. Equation showing the calculation of water horsepower, brake horsepower, and kilowatt. Look, my dear, by yourself. It's very important. Look, my dear, and note that brake horsepower equal to water horsepower divided by the pump efficiency. In addition, that the using of engine as its power and current required can be calculated as shown in the enclosed equation. Look, my dear, choosing the suitable pump is very important, as it depends on the required discharge, head, suction lift, available water source, static level of water surface in the valve, and draw down. In addition, it should be easy for operation and maintenance. All factors are combined into an absolute number of street speed, which is meaning its speed while delivering 1 cubic meter per second at 1 meter head, and can be calculated as shown in the enclosed equation. References, my dear, is very important. Additional reference, my dear, look by yourself. References and references, my dear. Additional and more. More reference, my dear. Important and important. Additional reference, my dear. Goodbye.